Alright guys, sorry about that. My computer died in the middle of me recording. So you'll have to pick this video up from the previous one. Make sure you're following them in order from the Google Classroom. So we had already listed all of our information from least to greatest. We had just decided there was 47 pieces of data. We added them all together and we got 1,235 divided by all of them, which is 47. So that's 26.28 total. The median is the middle of our data. So I start on both ends and I just kind of start crossing off until I find the middle. So I get 28 is my middle of my data. So median, I think of like the median in the middle of the highway. You guys are all learning to drive now. The median separates the two sides of the highway, so the median is in that middle. Remember, another name for average or mean is average, so if you think about it that way too. Okay. And then the mode, I see the MO in front, which means most often. And I'm just going to look up here. I see 4 4s. Do I have more of anything else? Looks like everything else is 3. So yes. So my most often number is 4. I range from 66 to 1. So I do 66 minus 1, which is over 65 numbers. So then we kind of have to look at this skewness here. We notice that if we turn our data this way, you guys can all do this, that most of our data is up front here. Most of this data is up front. There's like nothing over here. It's like all in the front, which means that it has a longer tail to the right. So our distribution shape is right skewed. All right. Excellent. There's less numbers here. So 13.6 means 136. So these are bigger numbers here. So I'm going to list out all those numbers. So I have 136. 139, 139, 142, I have 143, 4 times, I believe. Yep, 144, 146, 147, twice, 148 and 149. Then I go to 151, 153, 154. Looks like it didn't all fit there. So it went down. 1 second. 156, 157, and 162 and 164. So remember, when we're finding the mean, another name for that is the average. We need to know how many we have. So I have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So whatever I get, I'm going to divide by 21. So I have 136 plus 139 plus 139 plus 142 plus 143 plus 143 plus 143 plus 143 plus 144. And I go 146, 147, 147, 148, 149, 151, 153, 154, 156, and 157. And then I have 162 and 164. So I add all those numbers together and I get 3,106, and I have to divide that by the total that there are. So I divide that by 21 and I get 147.9. So my mean is 147.9. My median is the middle. So I take my pencil and I just go back and forth until I reach my middle. My middle number is 147, which these two are really close, which is always good. If they're close, that probably means your data is not very much skewed, which is good there. Your mode, your most often, I see 4 143s here, so I think that's my most often. I range from 164 to 136, so I do 164 minus 136. Not times 136, I do minus that, and I get 28. So the data range is 28. And then when I'm looking at this, I look at my shape. You could say it's slightly right skewed or bell-shaped here. It doesn't matter which one you would say here. I'm going to say bell-shaped. It might be slightly right, but it's not by much if it is. All right, so that's the measures of central tendency. Again, measures of central tendency are mean, median, mode, and range. Mean is your average. You add them up and divide how many you have. Median is the middle. Remember, think of that median in the middle of a highway to protect you from the cars going the other way. Mode is most often. Think of that MO. And range is the biggest minus the smallest number. So you always need to make sure you're listing your data from least to greatest. So what about the box and whisker plot? The box and whisker plot is a good thing to know how to read. So a box and whisker plot displays a data set along a number line using medians. Quartiles divide the data set into 4 equal parts. The median, second quartile, divides the data into 2 halves. The median of the lower half is the first quartile, and the median of the upper half is the third quartile. So I'm going to make this a little bit darker here, so you guys can see it better while I am doing this video. Okay, so when you're looking at a box and whiskers plot, you'll notice you have points on the end and then you have these 3 lines in the middle. The very middle line is your median. So when we were finding our data set on the previous slide here, our median for this one was 147 and our median for this one would be 28. That would have been the middle part there. But then you have these quartiles, which are also medians as well. So this is your first quartile, and this is your third quartile. These medians actually come from the data as well. So we notice that our median here is 147. So if we were finding the median for our first quartile, we would go from 146 or 136 to 146, and we'd find that middle number again. So we'd go and find our middle number. So I have 2 middle numbers here. So my first quartile will be 143 plus 143 divided by 2, which is still 143. So in this case, that would be this first line here. Now, our third quartile is for our upper set of our data. So it's from that 147 to that 164. So again, if we look at what we have here, we are between 153 and 154. So we add those up and divide by 2 and we get 153.5. So that's where that would be. And then we do our least and our greatest value. So our least value here was 136 and our greatest was 164. So that's kind of how the box and whisker plot is actually set up. So if you're looking at this, our least value is here at 2. Remember, we have our first, our median, and our third quartile are our lines. So this is your third quartile here at 8. I'm skimming around here. Our median is right in the center of the data here. The middle number there is median, which is 6. Our greatest value is here at the end, which is 10. Our range goes from 10 to 2. So I do 10 minus 2, which is 8. So our data spans 8 spaces on that number line. And finally, our first quartile is that first line, which is at 5. So we're going to have to know what those words mean as we are looking at these data sets in the next couple here because you got to know how to interpret this stuff. So let's look at this box and whisker plot down here. So the box and whisker plot below shows the volunteer service hours performed by students at Indian Trail Middle School last summer. So let's first, before we do any questions, know what these mean. So remember, this is my lowest point. This is my greatest value. This is my median. And then these are my quartiles, my lower and upper quartiles. So I have my first and my third here. So one of the things you need to understand is if you're looking at this data, it is actually splitting it into equal pieces, like 4 equal pieces if you're looking at it, because like our middle is here. So it has an equal number of data here as it does to here, as it does to here, as it does to here. So it splits it up into 4 equal pieces, which is 25%. So like this is 25% of the data, this is 25% of your data, 25% of your data, and 25% of your data. So that's important you also understand that the same amount of data is within that, even though one might look longer than the other. So what is my median? It looks like my median is here at 20 hours of service. I'm using my units there. My lower quartile, or my first quartile, is, first can be my lower, just so you guys are aware, that's another name for it. It looks like it's between 16 and 17, so I'm going to say 16 and a half hours, about. My upper quartile, or my third quartile, is another name for that. Upper or third is here at about 23 hours of service. And it says what percentages of the data is between the lower and the upper quartile. So that goes back to what I'm saying here. This is 25, 25, 25, and 25. So between my lower and my upper, those are 25 and 25. So it is 50% of my data. It's not saying that there's more or less because the one side has a greater whisker or the other. And then the shape of distribution here. So my middle's here, and this looks pretty bell-shaped to me. Pretty even on both sides. All right, so that's those first ones there, interpreting them. So let's look at another one. So an electronic gadget distributor distributes various brands of mobiles to retailers. The data for numbers of smartphones, this is the number of smartphones, so I know what it is when I'm looking at my units, distributed in 9 months between January and September, are collected to make a box and whisker plot. Read the plot and answer the questions. Okay. So again, let's look at this. This is my least. This is my greatest, just understanding what we are talking about here. Median is here. My first or lower quartile. My third or upper quartile is here. Okay, so, and remember, each of this is split into 25% of my data here. So even though it looks like there's more data here and here, it's still 25% of the data total. The numbers might just be more spread in that period. Okay, so the median looks like it's at about 40 smartphones. What is the least number of smartphones distributed? Let's follow that down. So that's 30, 31, 32, 33, 34. So that is 34 smartphones. So write the number of gadgets in the upper 50% of the plot. So the upper 50% of the plot is from here to here. So it spans from, so that's 50, 51, 52, 53, and 40. So remember, we said each section is 50%, even though that is more spread than the lower part, the lower 50%, and is still the same amount of data. So it goes from, so it's 40 to 53 smartphones. And just looking at this one, I can tell it's not evenly distributed. It's not a bell-shaped curve. If you look here, we definitely have a longer tail going to the right. So this is right skewed. Okay, one more, and then you have another that you need to watch, and then you can work on your homework. So again, we're still talking about cell phones here. The double box and whisker plot compares the battery life in hours of 2 brands of cell phones. So we have brand A and brand B. What is the range of the upper 75% of each brand? So remember, this to this, each little section is 25%. So 25, 25, 25, 25. So this is the upper 75% here for this one. And it wants to know the range. So I'm going to take that biggest number, which is 7, and my lowest number, which is like 3.5, and do that. So my range there is 3.5. For brand B, we start here and go to here, because remember it's 25, 25, and 25, which makes 75% for the upper part. So my upper point is 6. My lower point is about 3.3 maybe. So if I do 6 minus 3.3, I get 2.7. So which battery life has a longer life? And you're going to explain. So I would look at this a couple of ways here. So this is the number of hours. You'll see that the highest point for brand B is 6 and the highest for brand A is 7. So that makes me think brand A has a higher one. You'll also notice that the median is higher for brand A than brand B, which makes me also think that more of that data is there as well. So I am going to say brand A because the median is higher. And because 7 hours is more than 6 hours, which is the higher point. All right, you are done with those notes now.